Greetings, pre-calculus students, to another lesson in our unit on sequences and series. In the previous lesson, we saw how to find the sum of a finite arithmetic series, where we saw that method that supposedly 10-year-old Gauss used to find the sum of the first 100 natural numbers. In today's lesson, we're going to continue with that idea of finding the sum of a finite arithmetic series, except we're going to look at a couple of different problems. We're going to look at one problem in which the sum is already given to us, and we have to use that information to find something else about the series. And then we will also look at a word problem dealing with this idea of finding the sum of a finite arithmetic series. So, quick recap. This was the formula that is basically just the method that Gauss used, where you have n, which is the number of terms, times the quantity a sub 1 plus a sub n, which is the last term, all divided by 2. All right. So before we get to that, though, just in case the bell ringer was not covered in class, let's quickly look at it. So evaluate the following finite series. So we're given a series. Now, really quickly, because this is important, remember the formula that we just saw in a couple of slides ago, we can only use that formula when we have an arithmetic series. Well, how do we know we have an arithmetic series? Well, we look at the expression. If we look at the expression, right, I hope this jumps out to you as being linear, right? Or it jumps out to you as the explicit formula of an arithmetic sequence. So it's definitely arithmetic, so that means we can use that formula. So we know this sum is equal to n times a sub 1 plus a sub n, all divided by 2. Well, how many terms are we doing? Well, let's see. We start at 1 and we end at 15. So that means we have 15 terms. How do you know? Well, you can just count it. 1, 2, 3, 4, 5, and you end up with 15. So we know n is 15. We know n is 15. So a sub 1 plus, and since we know n is 15, I can put in a sub 15 there already, all over 2. Well, what is the first term? Well, we find the first term by just plugging in 1, right? So a sub 1 is going to be equal to 2 times 1 minus 15. So that is 2 minus 15, which is negative 13. And then let's find a sub 15 as well. A sub 15 is equal to 2 times 15 minus 15. So that is 30 minus 15, which is 15. Now let's plug all that into our formula. So 15 times the quantity, negative 13 plus 15 divided by 2. So now we just add the two numbers up in the parentheses first. So negative 13 plus 15 is positive 2. So we end up with 15 times 2 over 2, which is 30 divided by 2, which is 15. So our sum here is 15. The sum of this series is 15. So that's number one. Now let's look at number 2. Find the sum of all even numbers up to 100. All right, so even numbers. So 2, 4, 6, 8, ... all the way to 100. So we're going to find the sum of all those numbers. Well, how many are there? Well, we know that there are 100 integers from 1 to 100. So since we're only doing the even ones, that means we're going to have 50 of them, right? Because it's going to be half. It's either your odd or your even. So you're going to have half of 100, so you're going to have 50 of them. So if we look back at our formula, so S is equal to n times the quantity a sub 1 plus a sub n over 2. We know we have 50, 50 of them. So a sub 1 plus a sub 50 all over 2. Well, what is a sub 1? Well, that's just the first term. What is the first even number? It would be 2. So a sub 1 is 2. And what is the 50th term? Well, the 50th term would be the last even number up to 100. So that would be 100. So now we plug everything in. So we end up with 50 times the quantity, 2 plus 100 divided by 2. So that would be 50 times 102 over 2. So let's see, what is that? Was that 5,050? No, I got that wrong. 5,000, wait a second. Just use a calculator. I was trying to do it in my head, but, 5,100. Gosh darn it. 5,100. So 5,100 divided by 2. So now we divide that by 2. Let's see, what do we get? This one I should be able to do in my head. So 2550. 2550. Let's see, did I do that correctly? I did. Awesome. So 2,550 would be the sum of all the even numbers up to 100. So that was a quick run through for the bell ringer. Now let's get to the lesson itself. So first question. So like I said before, just as we can use the terms of an arithmetic sequence to help us find a sum, we can also use the sum of an arithmetic sequence to help us find certain terms. All right? So example 1. The sum of the first 15 terms of an arithmetic sequence is 300. If the first term is 7, what would be the 15th term of this sequence? All right. So remember, we are using this formula. S is equal to n times a sub 1 plus a sub n over 2. Well, let's see. They tell us how many terms. 15. So we got 15 terms, that's n. They tell us the sum, that's s. They tell us the first term is 7, and then they're asking us for the 15th term. Or in other words, they're asking us for the last term. All right, so let's see. Let's plug in some of these numbers. So we know n is 15, so 15 times, we know the first term is 7. We don't know what the 15th term is. And we know that the sum is equal to 300. So this whole equation is equal to 300. So we're going to solve this. So let me write it off to the side here. So 15 times the quantity, 7 plus a sub 15 over 2 is equal to 300. So let's get rid of that 2 first by multiplying both sides by 2. Get rid of that 2 first, multiply both sides by 2. So we end up with 15 times the quantity, 7 plus a sub 15 is equal to 600. Now let's get rid of that 15. Divide both sides by 15. Divide. So we end up with 7 plus a sub 15 is equal to, what is that, 20? No, not 20, 40. And then finally, subtract both sides by 7 to get that variable by itself. So a sub 15 is equal to 33. And that's it. Okay? So the key here is really being able to identify what information are you given, right? So first 15 terms, that would be our n. The sum is 300, so that's our s. First term is 7, so that's a sub 1. And they're asking us for the last term. If we're doing the first 15 terms, that means the 15th term would be the last term, so a sub 15, or a sub n, in other words. And then you solve it algebraically. So that's going to be your first checkpoint. Okay, that's going to be your first checkpoint. So once again, this is going to be on your own. All right. So it's just like the previous example. So now let's look at a word problem. So an auditorium has 20 rows of seats. There are 20 seats in the first row, 21 seats in the second row, 22 seats in the third row, and so on. How many seats are there in all rows? So how many seats are there in all rows? So in other words, we're trying to find the sum of all these seats. We're trying to find what is the capacity of this auditorium? How many people can fit? Assuming there's no social distancing or anything like that. How many people can fit in this auditorium? Well, let's write out the numbers that they give us. So they tell us in the first row it is 20. And then the second row is 21, and then 22, and then 23, and then so on and so forth, right? So this is the first row, second row, third row, fourth row. So hopefully you can see that this is an arithmetic sequence. It has a constant difference of 1. It is linear. It's changing by the same amount every single time, just plus 1 every single time. Okay, so that means we can indeed use this formula. We can indeed use this formula. Well, let's see. Do we know how many? How many numbers? We do, because it tells us 20 rows. If each of these quantities represents the number of seats, that means we're going to have 20 of these quantities. Okay, so that means n is 20. Okay, so n is 20, so we know that. So n is 20, so a sub 1 plus a sub 20. Do we know the first term? We do. The first term would be how many seats are in the first row, which would be 20. So we know that as well. Now we need to know how many seats are in the last row. How many seats are in this last row all the way at the top, right? Because we need to know what that a sub 20 term is in the sequence. Well, you could just keep on counting, right? Because that's 20, 21, 22, 23, 24, 25, 26, all the way until you get to the 20th row, and you would see that it has 39 seats in the 20th row. So once again, for that one, you can literally just count with your fingers up to 20, and you would have 39 seats in that row. Or another way you could do it, is by using an explicit formula. Since we know this is an arithmetic sequence, we could just determine what the explicit formula would be for this. Well, what would be the explicit formula for this? Well, remember, the explicit formula for an arithmetic sequence is dn plus c, right, where d is the difference. Well, we just said that the difference is just plus 1, so d is just 1. And remember, c is just the 0 term. Well, if this is the first term, that means the 0 term would be 19, right? The number before 20 would be 19. So now we can just plug in 20 to find a sub 20. So a sub 20 would be equal to 20 plus 19, which gives you the 39. So that's another way you can do it. You could have also found the explicit formula and just plugged in 20 to find how many seats are in that last row. So it's 39. So now we can actually finally do the math. So 20 plus 39 over 2. So 20 plus 39 is 59. So 20 times 59 over 2. Let's see, 20 times 59 is 10,080 divided by 2. So it looks like the capacity of this auditorium is 540 people, or seats. 540 seats or 540 people. And that would be your final answer. Okay? So being able to recognize that a word problem like this is arithmetic, and then from there, setting up the sum formula, maybe using a explicit formula to determine what that last term is, which in this case was the 20th row. All right. The remainder of the problems in this lesson are on your own. Okay, so for example, this one, some of the integers from negative 100 to 300, some of the integers from negative 10 to 50. So for these, once again, you're just using that formula, n times the quantity a sub 1 plus a sub n divided by 2. So once again, you have to identify how many terms, what is the first term, what is the last term, so on and so forth, and then determine, so for example, how many numbers are from negative 100 to 30, right? For example. All right, and then 3 and 4, first terms of these two respective sequences. Now for these, the hint that I will give for 3 and 4 is because remember, to find the sum, you need to know what the last number is, right? You need to know what the last number is. You might need to find an explicit formula for these so that you can find out what the last term would be in the sequence. Like what would be the 10th term? What would be the 50th term? Okay, so that would be my hint for 3 and 4. And then for 5 and 6, here you are given series in sigma notation or using sigma notation. So number 5 should be relatively straightforward. I mean, there's a problem. The number 5 is just like the bell ringer problem. But number 6, the warning that I would give you for number 6 is careful. Look where it starts. It starts at 51. You end at 100. So be careful. You don't have 100 terms because you're not starting at 1. If you started at 1 and ended at 100, you would have 100 terms. But if you start at 51 and end at 100, I'll let you think about how many terms would you actually have for this series. Otherwise, that is the end of the lesson. As usual, if you have any questions, please feel free to reach out to me in the classroom, through email, during our meets, whatever you feel most comfortable with. But otherwise, I hope this lesson went smoothly. Hope you guys stay safe and enjoy the rest of your days.